Welcome to Study Loop.
Okay, so we're asked to express each of these system specifications using predicates, quantifiers, and logical connectives if necessary. For part A, we have at least one constant must be accessible during every false condition. So let's let E of x comma y mean that constant x is accessible during false y. That means that for all x or for all y, there exists some x such that C of x comma y holds. Okay, for part B, the email address of every user can be retrieved whenever the archive contains at least one message sent by every user on the system. So let's put M of x comma y to mean that the email address of user x has been, let me write it down actually, email of x sent to y is contained in the archive. And let's let P of x mean that the email address of x can be retrieved. Okay, so we have that there exists some y, and for all x, such that if we have that email of user x has been sent, or user x has sent message y on system that is contained in the archive, so that's M of x comma y. This means that P of x holds. Now, which part are we on? On part C. For every security breach, there is at least one mechanism that can detect that breach if and only if there is a process that has not been compromised. So let's let f of x comma y comma z mean that our path x connects, or actually, sorry about that, wrong problem. Let's let d of x comma y mean that mechanism x can detect a security breach. And let's let E of z be that the process z has been compromised. So then we have that for every security breach. So for all y, for all z, there's at least one mechanism that can detect that breach. So there's going to exist in x and exist in a such that x is not equal to a. Sorry about that. So for all x, or for all y, there exists some x such that mechanism x can detect breach y, so that's d of x comma y. If this is true, if and only if there exists a z such that process z has been compromised, so d of z. Now for part D, there are at least two paths connecting two distinct endpoints on the network. So let's let f, or actually a of x comma y comma z, mean that path x connects to distinct endpoints y and z. So then we have for all y and for all z, our endpoints, there exists some x and some a, such that if x is not equal to a, then this means that a of x comma y comma z and f of a comma y comma z, sorry, a of that. So these two are our distinct endpoints. For part E, we have no one knows the user on the system except owner who knows all the passwords. It's let P of x comma y mean that x of user y, and let's let j of x mean that x is sysadmin. So then we have for all users x, if we are a system admin, j of x, this means that we know everyone's password, so for all y, p of x comma y. And we also have an and statement that it is not the negation of the existing x. It's that if we are not a system admin, then and for all y, p of x comma y.